Assalamu alaikum, my dear students. How are you? Hope you will be fine and okay. I welcome you all into my today lecture. Today is our lecture number 19, Unit 13, Electromagnetism. Our today's topic is the time period and frequency of the electron projected to uniform magnetic field. Better to say time period and frequency of cyclotron. And the second topic is the E by M ratio. And the third is the velocity selector. So let us start from the point where we left the last lecture. In the last lecture, I told you about the force on the charged particle inside uniform magnetic field, and that force was F magnetic was equal Q into V cross B, if you remember in the last lecture. Then I discussed in great detail with you that whenever a charged particle enters into a uniform magnetic field, it experiences a force which compels the charged particle to move in a circular path inside the magnetic field. The, this is the force called the deflecting force, which only which only compel the charged particle to move along a circular path or along a circular track. And I told you this does not change the magnitude, that is the speed of the charged particle, it only change the direction. And this is why I call this force as the deflecting force. Deflecting force, because it only deflect the path of the electron. And then I discuss all the various cases regarding this. Now we will apply this to find out the frequency and time period of the electron as it moves around a circular path inside the perpendicular magnetic field. So you see that when the electron moves inside the magnetic field, there must be acting a centripetal force on the charged particle, and the direction of the centripetal force is always towards the center of the circle. Now this centripetal force will be provided by what? Because there must be some apparent agency which will provide this centripetal force, and this centripetal force will be provided by the magnetic force which acts on the charged particle inside uniform magnetic field. And we know that the centripetal force is, this centripetal force is M equal to, that is Fc is equal to mv square by r, and this equals Q into Vb, right? That it will equal to this, because the force is maximum here, because the charged particle is moving perpendicular to the magnetic field. Now we know that when the charged particle moves, if this is the direction of the velocity, then we know that this V is equal to what? R omega, right? That is the tangential velocity in terms of the angular velocity. So this will come out to be like M, and this V, let me simplify this one step further. Then we have the mv by r equals q into v. So as I told you that this v is equal to r omega into r, which is equal to q into b. Now you see that this will equal to this omega. We know that omega is equal to what? Omega is equal to 2 pi f into what? 2 pi f into q into b, right? Or this f equals qb into 2 pi m, 2 pi m, where m is the mass of the electron and q is the charge on electron and b is the magnetic field. So this is the frequency known as the cyclotron frequency. Now, what is a cyclotron? Cyclotron is the kind of arrangement which I show here. And cyclotron is actually a machine which is used to accelerate charged particle to high energy in order to investigate the nuclear structure. So for this purpose, we use the cyclotron, and this is the frequency to which the electron can be accelerated. And this can be done by electric and magnetic field, right? So the cross electric and magnetic field, the cross perpendicular electric and magnetic field can be used to increase the energy of this particle, where the magnetic field deflects the path and the electric field accelerate the charged particle, right? So the charged particle will accelerate as you see here. Look at this diagram here, and it is then accelerated, like for example electron or any ion, and then you just see hit its target. So cyclotron is used to accelerate charged particle to the higher energies, right? So that it can penetrate into the nuclei of other material. So it is used to investigate or study the nuclear structure. And what will be the time period? For the time period, since time period is what the reciprocal of the frequency, so time period will be 2 pi m into QB. So this will be the time period of the electron when it is or charged particle when it is projected perpendicularly to uniform magnetic field, right? So look, you see in this diagram, look here, this is the path of the charged particle, for example electron, as you see like this, and then here, and then like this, as you see. And this is what, so this is the mass of the electron, this will be the radius, and look, if it changes to a new position, for example, then it will be theta, and this, along this there will be a centripetal force acting on it, and this centripetal force will be provided by the magnetic force that acts on the charged particle inside the magnetic field, which only deflects the path. So, and this is all about what? This is all about the frequency of what? And the frequency of the cyclotron, right? So cyclotron is in fact a device which is used to accelerate the charged particle, right? For investigating the behavior of what? For investigating the behavior of the for investigating the nuclear structure, right? Let me move it further step down. What did happen to it? Okay. So let me adjust it somewhere here. Okay. Now our next topic is the E by M ratio, the charge to mass ratio, determination of what? The determination of E by M ratio, right? Now we can use this to determine what? We can use this relationship to determine the E by M ratio. Now, once when I derive the E by M ratio to you, then I will tell you the importance of the E by M ratio, which in your book is lacking, that why we need the E by M ratio or why it's so important. Like they have uh, just left the detail of the cyclotron frequency. They just mentioned that the frequency is date of the cyclotron, and was did not tell anything else. The next one is the determination of the E by M ratio. The E by M ratio can be found from the same equation. The E by M ratio is given, the E by M ratio. This E by M ratio is 2 V is the potential difference, twice the potential difference into the square of the magnetic field into R square, where R is the radius. Okay, this is what the potential difference to which the electron is accelerated, PD, to which the electron is what, to which the electron or ions are is accelerated. Okay, E is the charge on the particle, M is the mass of that particle, and V is this magnetic induction, and R is the radius. Okay, so in order to determine the E by M ratio determination, let us see that this E by M ratio, one important thing which I want to tell you, that this usually change our common belief about the smallest or the small particles, right? How? Let us see this. As we know that let me derive this for you, derivation. As as we know that whenever the electron is projected into the magnetic field, then the required centripetal force will be provided by the magnetic field, as you know. Now let us see this. As I told you, it will be equal to mv square by r, and this is equal to this will be equal to q into VB. But this Q is in fact what, the charge on an electron, so I will be writing V into B, and you know this one we will get cancelled with this. So the required equation, when I adjust this MV by R will equals EB. So the E by M ratio, this equation will be like this. E this EB, look, this EB will be equal as, I should write directly, right? Or we can say that this E by M ratio will be equal to what? It will be equal to V by BR. So this is the simpler form of what, of the E by M ratio equation, where V is the required voltage to which the electron can be accelerated. Now how we can find this oh, I'm so sorry, very sorry, this is not the voltage, this is the velocity of the particle, tangential velocity of the particle that is moving along a circular track inside the uniform magnetic field. Now I want to calculate this velocity. Look, we can calculate this velocity from where? From the energy equation, right? Here I will do it. As you know that, look, we know that the kinetic energy of the electron, right, it will be provided by what? It will be provided by the potential energy of the electron at that point, and that energy is equal to what? Yeah, the kinetic energy of the electron will be equal to what? The work done on the electron. So this kinetic energy is equal to what? Half, and it will be equal to mv square. And we know about this W, that is, we know what is potential difference. Potential difference is work done per unit charge, right, while moving it from one point to another. So what is that work done? It will be equal to Q into V. So definitely I may write it like this: Q into V. But you know that this will equals into what? This will be equal to M, it will be equal to M into V square into 2EB. I'll be writing it like this. Okay, or we can say that this the value of the V square. So what will be the value of this V square? Rather, I will just multiply this by what? By what I should do with it to make this thing E by M. Okay, the value of this V. So here the V square, it will be equal to 2 E into V by M. So if I square this, right, then that would be even more better. So what will happen? E square by M square into is equal to V square by B square into R square, and we all know the value of this. Let me take it down. Let me do it on another way. I'm sorry, I'm just stuck with it. And so to create more space like this, there are some features with which went wrong about this. Okay. You then later on when you arrive this point, you little bit forward the video. So okay, if this get you disturbed, definitely it will. But I'm sorry for that. You know that recording again and again is very difficult. So let us see that we have what? We have this E by M ratio will come out to be E square by M square. And you know what is the value of this V square? It is 2 into twice the charge on electron into the potential difference by M, and when we have the B square and the R square. So this cancel and this cancel, and the required equation is that E by M equals what? Twice the voltage into B square into R square, where this V is the potential difference to which the charge particle is accelerated. Now you know the main problem is that what is the significance of this E by M ratio? You know, I always usually interested in the results, right? That why we are studying this, and in fact, what does it do? And this tell us very important point. For example, look, I just want to give you one simple example, and the simple example is that you see that look, if we have what? If we have the E by M ratio, look, if I calculate the E by M ratio for the electron, right? The E by M ratio of the electron I'm doing here. Okay, and if I have the hydrogen atom or ion, the hydrogen ion, right? If I calculate the E by M ratio for the hydrogen ion and I write the result here, okay, and this is for what? This is for the hydrogen ion. Now, it is a very interesting thing since the E by M ratio is for the cathode rays, this E by M ratio is the same for exactly the same for all kind of the metals, but the E by M ratio here when of the electron, when we compare, it comes out to be greater than that of the E by M ratio of the hydrogen atom. Now what inference we can get from, right? What does this means? This means that the either the that is the this implies that the charge on the electron is greater than the charge on the hydrogen ion. What first inference I can draw? This can tell me that the charge on electron is greater than the charge on a hydrogen ion. The charge on what? On a hydrogen ion. Or the second important thing which I can get, that the mass of the ion, what? The mass of the ion is greater than what? Then the mass of the electron. The mass of the ion is greater than the mass of what? Mass of the electron. Better I would write that mass of the electron is less than the mass of the ion. And of course, the second part wins. Right? Why? Because the charge, hydrogen have only one particle in its nucleus, that is proton. Right? So definitely experiment shows that the charge on electron is the same as the charge on what? Proton. So this never happens. So which thing is what does this E by M ratio shows? This E by M ratio shows that the mass of the ion is greater than the mass of what? The mass of the electron. What does this mean? This means that the mass of the nucleus, yeah, the mass of the hydrogen atom comes out to be 1836 time roundabout greater than the mass of the electron. So that is the physical significance of the E by M ratio, which we are calculating, okay? And the next important topic is the velocity selector. This is very easy. Velocity selector or VN filter. Now what is it? It is a device which is used to it is a device which is used as a velocity filter to only to allow a particular velocity and to detain the rest. So velocity selector is known as VN filter, and it is a device with a perpendicular arrangement of electric and magnetic field which is used as a velocity filter for the charged particle. Here you see that we have what? That look, here we have the arrangement of the cross perpendicular electric and magnetic field. You see here the magnetic field is what? The magnetic field is perpendicular to the electric field. Here we have the electric field, right? This one. This is the electric field, right? Sorry. This is the electric field. And one we have the magnetic field. And the electric and the magnetic field are both perpendicular to each other. Here we have the accelerated charged particle, right? And here we have the particles undeflected, right? And we just want to find out the velocity of this particle. Here you see this is a 2D picture of it. So look, whenever an electron is projected or a charged particle is projected to uniform electromagnetic field which are perpendicular to each other, then there must be two forces acting on the charged particle. One, to accelerate the charged particle, it is because of the electric field, right? And the other, the magnetic field, which deflect the path of what? The path of the electron, Fm, and this one, Fe. Now, if these two forces balances each other, then the charged particle will pass through the cross electromagnetic field undeflected, okay? So let us see how. we can find this equation. So as we know that if the charged particle is passed through the region where both the electric and the magnetic field are acting on it, then the two forces may balance each other at one point, right? We know that the electric force which accelerate the charged particle, this electric force is equal to Q into E, where Q is the charge and E is the strength of the electric field, or this is the electric field intensity. And the second force which acts on it is the Q into VB. This is second. Now, when the two forces, when they balance each other, then what will happen? Then QVB will equal to Q into E. Q into E. Or what happens? This get cancelled and V is equal to E by B. So that is the velocity selector. The velocity for which the charged particle will pass undeflected is the ratio of the electric to the magnetic field that acts on the charged particle. Now let us see that look, the charged particle will be look, it will be deflected, right? That when if there are cases, for example, if V is not equal to E by B, then what will happen? Two things. For V is equal to E by B, as you see here, it will pass straight, undeflected, right? Like this. For what? For V is equal to E by B. Now there are other cases. If V is not equal to E by B, then what will happen? That is that V will be either if V is less than this V, if it is what? If it is less than the velocity select, the velocity selector velocity, this one, this can be written as the selector velocity E by B, then what will happen? The charged particle will be deflected upward, that is towards the uh, that is towards this E, as you see. Look, it will be deflected in the upward direction like this one, as you see, along E, remember. And if the velocity selector, if it is greater, if the velocity is greater than the velocity selector, then what will happen to the charged particle? Look, then it will just move in this direction, right, in the downward direction, as you see. So the charged particle may either deflected that way, or it may either deflected this way, or it may travel straight, right? And it all depends on the magnitude of this V. If it is equal, it will pass straight. If it is greater, then it will be deflected in that direction, like you may say in this case upward, though it is not. And look, we will be what? We will be either in the downward direction like this. Now charge particle will deflected in this way for V is greater than the velocity selected. So this is the uh, velocity of what? This is what for the velocity selector. Okay, so this is our today lecture. Inshallah, the next lecture I will explain to you the force on that is the next topic would be the torque on current carrying conductor inside uniform magnetic field. So see you next, inshallah.